Let's study some terminology related to global routing and BGP. At the end of this presentation, you should be able to explain some basic concepts and identify some basic elements of a network that is running BGP. Let's look at a basic example. Here we have a network with three autonomous systems, autonomous system 1, 2, and 3, represented by the green ellipses. Inside each autonomous system, we have four routers. For instance, autonomous system 1 has routers 1A, B, C, and D. These routers have different functions. For instance, 1A is actually referred to as an internal router, while router 2A and 2C are referred to as external routers. So this will be an external router, and external, or also could be called a gateway router. Another name for this routers like 1C and 2A is also called a BGP speaker. So these are gateway routers. So each autonomous system, notice that it's going to have both internal routers and some gateway routers or speakers. So for instance, autonomous system 2, this will be 2C will be our gateway router, and for autonomous system number 3, 3A will be our gateway router. Now let's think about what we want to achieve with BGP. And for that, let's look at the fact that we have here on the right, we have a network, and we just have the prefix of a network, and we're calling this prefix X. So it's a, for instance, an IPv4 prefix that represents a network or a group or a group of networks. And we actually want to make sure that, for instance, autonomous system 1 knows how to reach, or about the existence and how to reach prefix X. So what's going to happen is the autonomous systems are going to exchange information between them. So for instance, AS3 is going to send to AS2 a message that says, I am AS3 and I can reach prefix X. This kind of message is called a routing or route advertisement. Autonomous system 2 in turn is going to use BGP and is going to make sure that it tells autonomous system 2 is going to tell autonomous system 1, I am autonomous system 2, and if you go through autonomous system 3, you can reach X. So in this way, autonomous system 1 knows that it can actually reach X by going through autonomous system 2 and then going to autonomous system 3 and then reaching any prefixes that belong to X. Now in practice, the autonomous systems are not the ones that are in charge of sending these messages, but the routers that are part of the topology. So how does this work? So let's look at first at some additional terminology. Here we're going to illustrate what actually happens and how each pair of routers is going to exchange routing information over semi-permanent TCP connections. And what's going to happen is that the BGP actually runs over TCP, which is a transport protocol, and it uses port 179 for the connections between the routers. And what we're going to illustrate here is the protocol that I actually run. So for instance, these two gateway routers, 2C and 3A, remember these are gateway routers. These gateway routers actually talk between them a protocol called or referred to as eBGP, and where E stands for external BGP. And these dotted or dashed lines here between all the routers inside of each of the autonomous systems indicate that these are going to be iBGP connections. So we have two parts for BGP. The protocol that is spoken between the gateway routers and the protocol that is spoken between the internal routers. Notice that iBGP connections, they don't necessarily have to be represented with a physical underlying link. So for instance here, notice that there's indeed an IBGP connection between 1C and 1D, even though, let me show you this, even though there's no link between 1B and 1D in the actual network. Now, of course, with this terminology of EGP and BGP and gateway routers, now we know that what's going to happen is that prefix X is going to be announced by 3A as I am autonomous system 3 and I can reach X. And this is going to travel over eBGP to autonomous system 2. And autonomous system 2, this router here, is going to use IBGP, and is going to use IBGP to propagate the existence of the fact that we can reach autonomous system 3 and then also prefix X. And this message is going to propagate through the network, through the internal network using IBGP sessions, and eventually we're going to get to our gateway 2A. And this gateway router, remember 2A is a gateway router, is actually going to propagate a message that says that X can be reached through autonomous system 2 and then autonomous system 3, and that's going to go to using eBGP to router 1C, and router 1C is going to be using IBGP to propagate that information. So eventually, for instance, 1A is going to learn that AS2 and AS3 can help you reach prefix X. Now, in practice, there's not only one route to a particular destination, like in this simple example. Something a little bit more realistic could be like this, where there's an added link between autonomous system 1 and autonomous system 3. So in this case, there will be two routes that are learned by autonomous system 3 on how to reach prefix X. So for instance, autonomous system 1, the router is here. Let's say this router 1A is going to learn two things. It's going to learn that it can reach X using the path autonomous system 3, autonomous system 2, autonomous system 3, and then get to X. But it also has a choice of going directly to autonomous system 3 and reaching prefix X. And when you have these two options, then BGP gives you a procedure on how to select the one that you're going to use. And mainly that procedure, the first criteria of the procedure, is policy. And we'll discuss that in a separate video. Now, in order to construct these routes and to select the route that we're going to use, we need a little bit of extra terminology. And the router advertisements that we had here, remember these were router advertisements, they're a little bit more elaborate than the description that we include here, where we have the autonomous systems that we need to go through to reach a particular prefixes. And they actually contain what's called a BGP attribute, or a list of BGP attributes. And the ones that interest us right now are two attributes: the autonomous system path, AS path, and something called the next hop. So let's start with the autonomous system path. The AS path of a routing advertisement is going to contain a list of the autonomous systems through which the advertisement has passed. So when a prefix is passed to an autonomous system, that autonomous system is going to add the ASN number to the existing list in the ISS path and the autonomous systems path. So that's what we saw here. Remember when we said that autonomous system 2 is going to add its number to the advertisement that it got. So it originally got AS3X and it added to the list AS2, AS3X. So that's the path, the autonomous system path. Now, one interesting feature that comes with knowing the path that you can follow to reach a particular prefix is that if an autonomous system sees its own number in the path to reach a particular prefix, it knows that it cannot use that path, because eventually that packet sent to a prefix is going to come back to it. So if a router sees its own ASS number in the path, it's going to redirect the advertisement because a looping path is going to be created when it tries to reach a particular prefix using that path. Now remember, there's two attributes, the autonomous system path, and the other one is referred to as the next hop attribute. And this is the one that we're going to use to link the inter-autonomous system routing protocol like BGP with the intra-autonomous system routing protocol like link state. And the next hop, it's really just the IP address of the router interface that begins a particular path. So let's see how that works. So remember here in our network that AS1 is going to receive the message or the routing advertisement AS2, AS3, X, and it's also going to receive AS3, X. Now in practice, what it's going to be received is not just this, but it's going to be a message of this nature. And the message of this nature means that AS1 actually knows how to use any of these routes towards the destination. So a BGP route is going to be created by the next hop along with the autonomous system path along with the destination prefix. So in practice, what's going to happen is that, for instance, in this case, the next hop to go from autonomous system 1 all the way to prefix X will be to use the interface that connects 2A to 2C. So this interface right there. So for AS2, AS3, our next hop path, let's call this interface 1. It will be interface 1 of router 2A. And interface 1 router 2A is going to have a particular IP address. So in other words, the next hop is the IP address that you need to connect to in order to send the message through this particular route. In the case of the other advertisement where we are sending AS3, the messages to prefix X using AS3, then the next hop is this interface right there. We can call this interface, let's say, 3 for router 3D, and it's also going to have a different IP address, so we'll call it here IP address, let's say 3. There's one thing, the next hop is always going to be an IP address, and it's going to be an IP address of a router or the interface of a router that is not part of the autonomous system. So for instance, if you are AS1, the next hop is actually an IP address of a router in AS2 or the gateway router in AS2. And if you're autonomous system 1, the next hop for this advertisement AS3X is the IP address of a router, in this case router 3D in autonomous system 3.